Hello, I'm Charlie. I've been working in cybersecurity for nearly 10 years now across a whole range of industries. I've worked from central UK government to fintechs, startups. I've done consulting for BAE Systems, KPMG. I've worked in investment management, in insurance, and in all those roles I did cybersecurity. But more specifically, around 7 years ago, I got into what is known as DevSecOps. I'm teaching you what I have learned actually doing, implementing. I have built DevSecOps teams from the ground up. I've designed DevSecOps strategies. I've done this across different industries. I've been embedded myself as a DevSecOps engineer into engineering teams. So I got hands-on putting tooling as part of pipelines, securing AWS, doing threat modeling for teams. I've done that many a times over 6 to 7 years now. I've been doing actual DevSecOps, and I did it very early on. Not many people were talking about DevSecOps back then and shifting security left. So let's get into it. So this quote, and this is something, I wouldn't quite call it a quote, but it's something I always say when speaking to CTOs and other C-level positions. So for the first time ever, cybersecurity is being able to provide a greater value to the business through DevSecOps. So traditional security of organizations has rapidly changed and evolved. So companies, definitely pre-COVID era, had a lot of on-premise servers. They had a lot of physical hardware IT that, as cybersecurity experts, we had to try and protect because they were connected to the internet and connected to actual real servers that had personal data on, so we had to protect those. That's moved and changed a lot. So businesses in the post-COVID world are much more focused on securing their cloud infrastructure, and they have moved to that cloud model. So there's nothing on-prem, everything's gone to the cloud. Software as a service is really common. Using development pipelines, automation. It's all about being less hands-on and having less engineers and not needing to be physically near each other, etc. So as a result of that, the threat landscape for security has changed and it's moving to the cloud. And there's been loads of other changes from things like misconfiguration of infrastructure and code, etc. But DevSecOps is essentially the answer to that. But what this also means is by improving DevSecOps and improving how teams write code and build applications, we are also forcing the business to deploy more regularly, help with what's known as DORA metrics, which is like improving our mean lead time for changes and our mean time to recover and change failure rates, things like that can be improved through DevSecOps. And this ultimately saves the business. Saves the business money, time, resource. You can deploy quicker. And that helps because cybersecurity is a really difficult thing to sell sometimes. And what I mean by that is when you come into a business, you have to justify the budget you need to keep a company secure. And what can end up happening is you can end up spending loads of money, building a really big team, getting all the great tooling, and a year goes by and you sit down with the CTO or whoever you're reporting to and they go, well, how can you prove to me that you've actually, we've not had a cyber attack in a year? But that doesn't necessarily prove to anyone that the money you've spent has provided value. So providing that value is really important. And metrics in cybersecurity in general, because by its very nature, not being hacked isn't a good demonstration that you're doing cybersecurity right. And it's really hard to prove to those individuals that you're doing security right. DevSecOps actually allows you to do that. So this is why the roles get paid more. This is why more businesses want to do DevSecOps, because we're not just doing security, we're making the business move and build and become better. So that's why this is something I always say to C-level positions. It's about this natural evolution, and DevSecOps can provide many more benefits beyond just security. So at a high level view, during this lesson, we're going to be going through why DevSecOps. We're going to go through what a software development lifecycle is, what a secure software development lifecycle is, what are the typical tasks of a DevSecOps engineer, the kind of role traits that we look for in these engineers and what I've previously looked for when hiring people in these roles, the challenges you have in this role, principles. We're going to do a day in the life, and then we're going to look at the technical tooling using to support it, like SAST, DAST, infrastructure as code, pipelines, threat modeling, and some general tips on how to be successful in either doing a DevSecOps role, successful in creating a career that lines up for a DevSecOps role and doing the correct training, etc., as well as building out DevSecOps team and creating DevSecOps culture at a business. Almost every company in the world wants to do this. Hardly any companies in the world are doing it right. Some claim they're doing it, but they're definitely not. And very few engineers actually know how to do this or have experience in doing it. I'm one of those engineers in the world that's actually done it for many years in many different flavors at different companies and been very successful in doing that. So DevSecOps, so when we look at the name given, right? So we went from DevOps, okay? And then we came to DevSecOps, which is like this. Now, there's actually quite a few ways people do this. Some people call it SecDevOps. Some call it Ops SecDev. And then there's various other iterations. It all means the same thing, I would argue. Some people argue it means different things, but I don't think it does. And the main term that we go with is DevSecOps. What it means is this dev part. So the idea is that some of the skill sets within this role has a development background, but that is not actually needed for this role, because the development part of DevSecOps is about understanding how code goes from your Visual Studio Code, like actually your laptop, to a GitHub repository, what that process looks like, what a pipeline to deploy an application to production looks like, and where you can put your DevSecOps tools and processes as part of that process. Now that's where the dev part comes from. You do not need to be a developer to do this role. I just want to make that very, very clear. You just need an understanding of how that development process works. The security part is all about prioritizing risk versus business enablement, work versus teams working on different things that are not to do with security. So for example, when you embed with a team, if you were to embed with a team or you're working with a team to implement DevSecOps, they might go, oh, we want to put this process in place. We think it's the best thing to do. But as a security engineer, you might be able to say, well, actually, these are the threats and scenarios you should be worried about. Instead, do these processes. And it's that security knowledge of understanding the threats, the landscape, where that comes in. The operational side is about providing live direct input. This could be to production networks. It could include observability and how the applications actually run in production. So that's about putting controls and things in place for the live environments, the operational side of what you're doing. But in total, we can call it DevSecOps. And there's, like I said, there's many different flavors to how this is done, but we're going to be calling it DevSecOps today, and it's development security operations. Now, this will give you a bit of a better understanding on this diagram of how the world's changing. So as I said, the tech companies have very much gone from kind of on-prem to cloud, SaaS, and pipeline development. And every company you will see is at a different level of maturity. Not only is every company, but you might go into a business and find one development team is more advanced, another development team is less advanced. You will find that and you have to recognize that there's differences. And this will be really key in the strategy and how you actually successfully implement DevSecOps. But at a high level, what DevSecOps mean is this combination of skills where you can see, like, traditional security is about doing penetration testing, vulnerability scanning, writing security requirements, incident response. That was the traditional way of security. And then DevOps, which has been a slightly new trend as we've made that change to SaaS and cloud, but it's focused on AWS, Azure, other cloud providers, writing infrastructure as code, which is known as Terraform, pipelines, Kubernetes, etc. So it's this completely new model of IT and development coming together, hence the word DevOps. But then DevSecOps, as we are moving more and more to that DevOps and cloud first model and less on-prem, less physical hardware, the roles of security and DevOps are merging. And as a result, those skill sets and the people that you hire for need a combination of these skills, hence DevSecOps. And I think in a few years' time, we will actually see that there'll be very few traditional cybersecurity experts that only have hardware skills, and there'll be very few just DevOps engineers or just engineers that know cloud. It will be combining into DevSecOps. So this will become the new future role. So the demand for this will soar. So this is why it's so important to understand it and get forward with it. Now, I teach DevSecOps from a security perspective, which I think is the right thing to do, and I'll explain a bit later why. But some people teach DevSecOps from a DevOps perspective, which is slightly different. I think you need a combination. When you create a team, you would want a combination of skills so they can pull each other in each direction. But the core common theme is those DevSecOps skills. Some people will have more skills in other places, others will have others. The best thing to do is blend them together and benefit and recognize that as well. So why DevSecOps? So DevSecOps has come about as a result of that natural merger, but the problem we are trying to fix is the fact that applications, so when you build an application, and I've seen this time and time again, they will build a new application, all the engineers will write the code, do some testing, etc. Then they'll come to the security team and go, right, it's gone live yesterday, are we secure? And that's terrible, because the problem then is it's live, it's public facing, an attacker can exploit vulnerabilities in that application, and the security team are very much left having to bolt security on afterwards. And as a result, if you find problems in that application, which you likely will if they haven't created it secure by design, it's going to cost more money. You might have to tell the team to stop working. They might have to bring the application down from being live. Or worse, an attacker actually exploits a vulnerability and there's a big fine against the business, or the reputational impact of the business is irreversibly impacted. So DevSecOps is about shifting that security left, and I'll talk a bit more about that when we go through the SDLC, but shifting security left and finding those problems as early as you can before the application goes live. You don't want to be sat there at a table and someone comes over, we've deployed that new application. No, security should be involved right the way at the onset. So that's what DevSecOps is, one of the pros to doing that. And securing that application by design is about getting right the way at the start. So if they go, right, we're going to build a new application, they'll start writing out their requirements, the functional and non-functional requirements. You, as a DevSecOps engineer, need to put in your requirements as early left as you can, straight away, so the teams know they have to build in security, logging, monitoring, etc., and the SAST scanning and the different vulnerability scanning and automating all that before they go live into production. It saves the business money, the product's better, your customers will have a more secure product, and it's cheaper and it's engaging for the engineers building it. So that's part of the problem you're addressing. The very nature of this evolution of security and tech in general to cloud infrastructure, microservices, where you have like smaller applications all working together, that has meant that the threat landscape is much, much larger. So it is so, before you would just have one big application and you would just stick a firewall on it, you do a pen test, done, you're happy with that. Now, there's potentially hundreds of different moving components. There's serverless functions that are doing different things all over the estate, and it makes it harder to find and track those assets afterwards. So that's why you've got to shift it left. You've got to automate things. You've got to automate them. If everything is written as code, then you should be in code with your security tooling, making sure that everything's done there. Then you can trust that when everything goes to production, it is secure by design. Not only that, teams are deploying more regularly. So you don't, in the security profession, you don't want to be stopping teams going, we've got to do a pen test now, or we've got to do this, we've got to do this testing. No, it should be baked in, and you should be allowing teams to, and you want teams to promote code to production more regularly, because then all your little tests run and you make sure that all those different components are secure. So a lot about DevSecOps is actually creating the upfront automated processes. Once they're in, you hand them over to the teams that are doing them, and then you will just help monitor progress. If there's any changes to the app, you get involved on some light advice, etc. But the role is actually about doing that front up work. But the teams will always need that consulting advice. That will always, even when I've put in these processes in place, the teams still come back to you all the time about advice on, does this work? Should we refine this alert? Should we be blocking the pipeline? Should we keep it in passive mode, etc. But shifting security left is all about finding vulnerabilities earlier. Okay, and this also helps the secure growth of the business, right? So I've seen so many companies that have had to sort of stop building new products because actually their tech debt and everything they've done previously has been wrong. They've got to sort and get their house in order before they can start building, because then every time they're building new products, they're adding to the tech debt, they're not solving the problem. So shifting to a DevSecOps culture, bringing in a DevSecOps engineer as early as you can is the best strategy. Okay, so this here is what we call the software development life cycle. Right, this is what I would call a waterfall picture. So there's two terms you need to be familiar here in the DevOps world. One's agile and one's waterfall. Waterfall is about doing like lots of documentation, moving to the next step, building this app, doing this testing, moving to the next step. It's very heavy, it's not very iterative, and it's not very flowing. But an agile methodology is about constantly changing, moving parts, adding a bit of security and adding a requirement, then doing some testing, then coming back and going, and that's the best model to follow. So Google those terms if you want to understand a bit more about Agile and Waterfall. So this diagram looks waterfall, but actually it's meant to be front up. If you're building a big new application, there will be parts that are a bit more clunky, a bit more documentation. But once it goes into production, it should then follow that process again on any new changes, but be much more lighter touch and automated. So the blue, what you can see in the blue on this diagram here is the actual software development lifecycle that engineers follow, right? So you have your initiation phase, your design phase, development, testing, and then deployment, and then maintenance where you're coming back round. So that is how teams build code and make an actual application. That new app that you downloaded or that website you visited, the code has gone through this process or should do. Now it looks, different companies call it different things, different teams call it different things, and there's different ways of doing it, but that's not about this debate. So what I'm trying to teach you here is that actually at these different stages, you have to do different things in DevSecOps. Now, there's not a right or wrong way of doing this, but this is a high-level view of how I've sometimes done it. So during your initiation phase, and when we say shift left, what we're talking about, this is right, this is like production. Shifting left is getting things in at the initiation phase or as left of that life cycle as much as possible. That's what we mean by shift left. If we're too far right, we're already live in production. It's too late. It's out there in the wild. So we want to shift as much left as we can. Now, there's only so much you can shift left for certain processes, and I'll go through that in a minute. So at your initiation phase, if you join a new project and you're starting out, first of all, you want to understand what the critical asset's going to be. So what are the apps you're building? What's the data they have, etc. So you do a critical app assessment. You then want to look at writing functional and non-functional security requirements. With security embedded. So they'll have a requirement that says we need to make sure that all authentication attempts are logged, for example. That'd be an example of a security one. You could have, and then you'll have user stories. So as a user, I want to be able to have this functionality in the app. But what you can actually do is have attacker user stories. So you can say, as an attacker, I want to be able to attack the application, or anti-attacker stories where, you know, as a security incident response analyst, I want to ensure that I can stop an attacker doing this, or I see the logs of a user doing this. By getting those stories and requirements in, you're baking security in from the onset, and eventually those tickets will eventually get worked on and those requirements will get worked on. As we move into the design phase, we then want to do an inherent risk assessment, which is actually looking at the risks of the application. What is the impact and likelihood of certain things happening based on the data and how this application is built? Is the application public facing? Is it only internally facing? Is it B2B? Is it to a business to business rather than to customers? So all those things are taken into account so you can actually understand the risk. That inherent risk will help decide how strict the controls are you're going to be that you put in, because this is not a one fits all for every application. It should be changing and adapting to the inherent risk of the application. And if that inherent risk changes, then so should the risk profile and the controls you put in place. You'd want to do a security architecture diagram. So this is where you would actually draw up a high-level diagram of the data flows in particular and understand what are the the entry points to the app, how customers access it, and what that traffic flow looks like, as well as for internal users, and then what does traffic look like outbound, etc. Then you want to do threat modeling. Threat modeling is the single most important thing you will be doing as a DevSecOps engineer, because it helps you understand the threats, it brings them to life. You would always do threat modeling as a workshop, so you would do it with the actual engineers that are building the application. They will then start thinking about, the idea is to get them to think in the mindset of an attacker, so they can build the application as if that in a way to prevent an attacker. And you can only do that when you start putting these scenarios. And so many engineers that when I've sat in workshops, they've gone, oh, I didn't think of that. Or they'll put their hand up and go, actually, I think you can do this with the code, or there's this backdoor in the application that can do this, etc. So really, really useful. But the main reason it's useful is to be successful in DevSecOps, and I'll go through some of the tips later, it's about developing that rapport and having the engineers trust and believe in you. Workshops, FaceTime, getting on boards, drawing things is all part of that. Just coming in as a security engineer going, you need to turn this on, you need to have this rule in place, you're doing this wrong. That's going to make you no friends, and that is not going to successfully implement DevSecOps. I'll talk about that a bit later, but threat modeling and doing threat modeling workshops is absolutely key. Now we get to the development phase. During development, you want to, well, for a start, the team should be using Terraform to deploy their infrastructure. And almost every team will be deploying some infrastructure. So you have to make sure that infrastructure is secure. Now, you would usually use a tool to do that, like TFSec or some other tool that will scan and review it as part of the pipeline, or you can review the code manually yourself with the engineers and do pair programming. You then want to implement a SAST tool. So SAST stands for Static Application Security Testing. We've got a slide on that later in the lesson. But SAST will look at the source code, the code the engineers write. It will scan that for vulnerabilities before it goes into production. Then you also want to do something called SCA. So when engineers build an application, they don't always write the code. Sometimes they will use a third-party library or dependency that's in their code so they don't have to rebuild the code, which is, best practice. But sometimes when you bring in those third-party dependencies, they already have vulnerabilities in. So composition analysis scans those libraries for any vulnerabilities so that you know about them, and you can either update to a latest version, latest package, or decide not to use that library. Then you want to look at the whole pipeline end to end. So when you sit down with the team, draw it out and go, right, how do you get your code from your IDE to production and what that looks like so you can understand where you can put processes and things in. Now, during each of these iterations, usually you would have some sort of what's called an SWG at the top there. Very waterfall-y, and it's not practical to always do it, particularly when the team's in production, but it stands for Security Working Group, and it should usually be some sort of meeting that you would have with the engineers to make sure they're on track, any help that you can work with, etc., and help do sign-offs to make sure they're going in the right direction. When you get to the testing phase, you're getting close here to doing some sort of security sign-off before production. You want to make sure that the rules on your web application file are customized to the application. The threat modeling will highlight that. I'll talk about that in other sessions. And you also want to put in place what's called a DAST scan, which is dynamic application security testing. So this is a bit like pen testing. It's where you have usually you'd use something like a tool called OSAP, but a tool will hit the application and rigorously test it as if it was being attacked. Then we get into deployment, we get into production. Here you want to make sure that you do pen testing before you go live, and you want to do it on production. You preferably want to do it on staging if staging mimics production. You want to make sure the team's got the right security alerting in place, your incident response playbooks or runbooks are up to date, so you know what to do in the event. And then you iteratively follow this process on any new changes. Now that means being less document heavy, but more putting those automated checks and plans in place. The moment new code's deployed, the moment new features are deployed, you want to make sure that's covered. So this is the SDLC. This is actually the SSDLC, the Secure Software Development Lifecycle, and this is how DevSecOps works on one page, essentially. So now we start to look at the tasks that would be expected as a DevSec engineer, or whether you're part of a DevSec team or you're trying to make a team turn them into a DevSecOps culture. So, and these are just some of the tasks, things that I've done before in the past, ideas that you could do. Again, there's no right or wrong real way of doing it. DevSecOps is more about a culture, but the ways to do it, there's a million different ways to do it depending on teams, etc. So I'll go through this now. So one of the first things that you would want to look at potentially doing is embedding. So I would recommend if you're joining an organization for the very first time and you're going to be implementing DevSecOps, I would recommend you embed with an engineering team. Even if the organization has 100 engineering teams, embed with one of the teams just to get an understanding. And by embed, I mean you'll join their stand-up. So an engineering team, think of them as a separate team. Each morning they'll have a stand-up, which will be like a meeting where they discuss what they're working on. Then they'll go off and pair program together. Then they might join together on something else, etc., or do a refinement and things. So embed with one of those teams, even though you're coming from the security background. Embed with those teams, and so you get familiar with how they work, what their pipelines look like, etc. This builds up your understanding of how you would potentially roll out a wider plan or project of DevSecOps at that business. So embedding is really key. Now I've embedded myself. When I first got into DevSecOps, the first thing I wanted to do was embed. I was like, get me an engineering team. I want to embed. I want to put the tools in place myself and understand those working practices. So embedding is really powerful. DevSecOps Champions Program or a Security Champions Program usually requires you putting together central documentation and training and going out and training current engineers that are interested in cybersecurity as the champions in the business. So it's a way to extend your reach across the business, particularly if you're on like a really large organization that has hundreds of engineering teams. Realistically, you're not going to have embedded engineers in all those teams. It's not really going to work. You're going to want to create a champions program where you get all those champions together from all those different teams and they talk about security. You train them in threat modeling, how to implement SAST, DAST. You'll probably still put in place those centralized tools with guardrails, but they'll go off and do those things. And you'll use those champions to change that culture. So embedding champions, they are two different things. I'll do some more sessions as the weeks go on this and do more webinars about this as well. But I've done both. It depends on the organization, but both are Very, very useful tools, the most important tools for actually getting DevSecOps right. Next, you need to educate engineering teams. Whether that's through an embedding or a champions program, you might want to go out and do monthly meetings with the kind of engineering managers, or do brown bag sessions or whatever, but you've got to get out there and educate them on DevSecOps, what those working practices are, start having them open up to security and understand the benefits to it, which I will also go on to as well. Threat modeling workshops, I mentioned this earlier, threat modeling workshops are the best way to, so it will be like you would literally ask the engineering manager, tell me all the engineers in those engineering teams. They'll give you a list of the engineers. You'll go away, create a meeting, put something in their calendar for like 2 hours, say. And what you'll do is you'll ask some questions up front on what are the apps that they build and what are the products and what does the infrastructure look like. You'll go away, you'll draw all that together on a high level diagram, and you'll put together slides that show all the different attack methods for those applications. So you'll go into the workshop with a predefined presentation. However, you'll have the workshop as being open for people to come in, etc. So you might have some blank pages where you'll add notes about the different attack methods for this application, but you want to do some front up work as well. Now, I will definitely do future sessions purely on threat modeling. It's such a good task to do as an embedded engineer and as part of your toolkit. Strongly recommend it. You can't do DevSecOps without proper threat modeling. There is also ways to automate threat modeling with various different tooling, etc. But being face-to-face, being in person, drawing stuff on boards, or doing it remote is fine. But just them seeing and changing that way of thinking and understanding security is so important. HLDs and data flows, yeah. So when you join teams and when you do DevSecOps, even at the highest level, you want to see what are all the apps that I'm meant to secure. So you do this with what's called a HLD, which is a high level diagram. Hopefully the team's already got them. If they don't have them, you're gonna have to probably draw some yourself and draw out the data flows. So follow the data, draw out the infrastructure diagrams. Again, I'm gonna do slides on this in the future. One of the things you're gonna do, one of the tasks you're gonna do is help fixing findings for teams. Now, you wanna get to a model where the teams are fixing the findings themselves. However, you need to teach them on understanding which ones to focus on. They need a DevSecOps engineer to provide that context and say, guys, this is what you need to worry about. These are the threats, the scenarios, the vulnerabilities you should be fixing, and help put them together a roadmap. And there's always going to be a requirement to have that central knowledge to come to. With champions, you can start educating and changing that, but it can take many years to actually get to that point. But that's definitely one of those things. And providing that context is so key, but engineers just don't understand it. Across team advice. So one of the big benefits, and I would argue this is probably maybe the single biggest benefit for DevSecOps, you'll find, unless teams have like agile members and stuff in them, you'll find that a lot of engineering teams don't really talk to each other that much. So the DevSecOps team and the DevSecOps function can help bring those teams together on things that are not just security. It improves product, it improves infrastructure, it improves working practices, and just engineering excellence in general. And then writing custom WAF rules. This is really key. How it should work is your firewall rules should be customized to the application. So for example, if you're blocking people from reaching your application based on the firewall, you need to make sure that the traffic's right, the expected behavior on that application is right. How many requests do you usually see during a time period for that app? And then you can tailor it on the firewall for what we call denial of service protection and reduce those thresholds. So it's all about providing that context. So these are just some of the examples. There's a million different things you'll be doing. You'll be putting in SAST tooling and stuff, and I'll go through that later, but this is some of the tasks you'll be doing. So what are the traits? So this is really key, because obviously if you want to become a DevSecOps engineer, you have to think, right, they're the skills I need, but what are the kind of characteristics, what are the traits I need? So the typical DevSecOps role is quite consulty based. And what I mean by that is a lot of the time you'll be providing advice rather than just getting hands-on. Oh, you will be expected to get hands-on, you expect to have a level of knowledge, but a lot of the time it's joining random meetings with random teams about a new app they're building, and they want a bit of advice on how to do this, how to do that. So you become a bit of a consultant as a result. And you can Google consulting and consulting traits, but the idea of this is being very open with team. I'll talk about this in a bit, but the consultant skills are about coming in and providing value, providing advice, being prepared when you come into meetings, being a really good signposter. And what I mean by that is when you go into a meeting, you go, well, actually speak to this team, speak to this person. You'll become that central body of knowledge. So consulting skills, having a soft approach to working with teams is really important. Engineering thinking for solutions. So this is why I said it's so important. And this is why you've got that dev part as the role title in DevSecOps, is that you need a really broad depth of knowledge from engineering. So you don't want a deep knowledge of particular subjects, because leave that to the experts, leave that to the actual engineers themselves. But they want to know what's the best tool to use, how's the best way to do it. So you need a high level breadth of engineering thinking for different solutions, which is really beneficial. Listen to engineers with empathy. So I'm going to come on to the challenges a bit later in DevSecOps, but so for example, if you find a problem or a threat or a vulnerability that needs thinking, you have to, when you go to the leader in that team, or when you go to that team, you've got to think, okay, before I go to that team, how are they going to feel about me approaching them? Because some of them might be, this is code they've written, it's their product, it's their baby. Like, they've spent so much time on building this. You want to come in and tear it apart and say, you've done this wrong, the app looks like, that doesn't work. So listen with empathy. Think from their perspective what that's going to look like when you go. So what you want to do is you want to go in and you go, oh, really love the application, love these features, really great. By the way, I've found this. Let's talk about how we're going to address this. It wasn't your fault. You couldn't have known this. I spotted it with my team. You know, that's listening with empathy. And that then moves us on to the next one, which is develop rapport. By listening with empathy, by thinking like an engineer and having those consulting traits, you will start to develop rapport. And developing rapport as a DevSecOps engineer is the single most important thing you need to do. Because if you gain the trust of the engineers, if they become your actual friends, they'll be really open. They'll tell you all about their code base, the application. They'll help you get involved. You've got to develop rapport. Be open to teams, so be honest with them, be open with them, help them understand deadlines you've got, deadlines they've got, so you can come to a compromise on what projects you've got to work on. And you're there to help. Like, make that very clear. You are helping them improve their code, improve their product. You're letting them sleep at night, not worrying about security vulnerabilities they've got, etc. Challenges. So I've had lots of challenges, and it's important to be aware of them when you come in. So not all teams will welcome change. Not all teams will. So, and there's anyone in a DevSecOps role, whether you're embedding or not, you're going to be working with engineering teams, different engineers. Like, absolutely. If you're not, you're not doing DevSecOps. So not every you will find some teams will be really pro security and they'll want you to come in. You'll find some others that won't. Or they'll think that they're already doing security and that they're security experts and they don't need you. It's more common that teams welcome and want you there as opposed to not, but you will have some individuals that will want to ruin it for everyone and think they're the experts. So those individuals you have to sit with, develop the rapport and listen with empathy, and you can help disarm them. But not all teams will welcome change. So you need to be aware of that. And those teams you need to spend a lot of time on helping build that trust, and you can. I've turned teams completely around. They've completely understood what I'm about and how I work, and yeah, it's just about selling it really. Security involved too late. Yeah, I said this earlier about the SDLC. If security is involved too late, sometimes teams are a bit worried about what that looks like, what that is for their product. You need to explain it. It's not too late to put security in place. Let's come up with a roadmap and a plan on how we can integrate security. Left. Firefighting. What will happen is as you start to go around teams, they will start coming to you for problems and problems and problems. Now, you want to create the processes and tooling to enable them to solve them themselves, to be self-serving. If you don't do that, you'll be stuck and bogged down with firefighting, and it means you'll just be joining meetings all day about various different problems, and they'll think you're the one that solves them all. So don't get bogged down in firefighting. Balancing security with product development is really, really key. It's sort of part of listening with empathy, because that engineering team there is to build features and develop a product. Balance, when you find security things, you always have to think, well, actually, okay, there is this security risk. This can or can't be exploited. The engineering team have to work on this other stuff, otherwise there isn't a product to protect because they're not building the product. So how do we get that balance right? And you've got to work with the managers to make sure that that balance is right. And you've always got to bear that in mind. And that is, again, part of listening with empathy. So some of the key principles of DevSecOps. So in general, this is not just at an individual. Secure by design. So I mentioned this earlier. Integrating security as far left as possible, making everything secure by design. Embedding by design, making sure your processes, not just yourself, but the tooling, the automation is all embedded by design. Automated, everything's automated. You do not want to be doing manual processes. There might be more manual in that kind of upfront new product phase, but after that, everything has to be automated. That will take time. That's not going to happen overnight. And you might have to have some manual process still and some automated, etc. But it depends on your scalability. And if you want to scale, you need to automate. Context-based security. DevSecOps has to be about what is the risk we're trying to actually solve here and mitigate. Is this worth the time of putting this in? Or actually, should we do this at a later stage? Everything's got to be context-based. Cloud first is really key. Everything's got to be SaaS. Everything's got to be in the cloud. Don't want to be running tools or anything on-prem or anything that you've got to maintain and patches. You don't want to be doing that. Business enabling is probably the key principle. If the team cannot create new products, do what they need to do whilst doing security, there's no point in security. There's no product to protect, there's no business to protect. And you have to make sure that when you join teams, you explain that. You're there to help them, that the things that you're doing are going to improve their processes, allow them to create more products. You are there to enable them to do their jobs. Without you, they're bogged down in fixing vulnerabilities that they shouldn't have. You're there to help enable them. That's a really key selling point. And scale appropriately. So like I said, whether you go with champions, whether you go embedding, you've got to look at all the engineering teams. How can I, in my position, have the most impact at this business? You might not be able to embed a tool. You just do an example team and create a strategy, do champions because there's too many teams. You might be able to, there might only be a couple of engineering teams. Embed with them, get hands-on. So it all depends on the business itself. So what does a typical day in the life look like of a DevSecOps engineer, and what would your potential future day look like? So it would usually start up with a stand-up. This could be a stand-up in your centralized DevSecOps team or security team. You then might join stand-ups of other teams that you could be embedded in or teams that you're working on. And during those stand-ups, they're usually only 10, 15 minutes, sometimes a bit longer. You'll go through what's known as Jira boards. I cover that in other videos as well. And you'll look at the tasks people are working on the day. People say, oh, I'm working on this. And they'll say, oh, can you help me with this PR? Can you do pair programming with me, etc. You might be able to say, oh, actually, don't do that yet. We're doing our pen test on Wednesday. Don't touch anything. It's there for you to give updates, them to give updates. That's how your day usually starts, with some stand-ups. Then you might have a task where you're going to write some new security requirements for a product team. So a new app's being built. They want to know what requirements they need in their boards. You'll start writing all those security requirements that I was talking about earlier, and you'll spend some time doing that. You might then have to jump on a call, maybe with AWS or with a customer or a third party, and talk about AWS authentication, how you're going to enable different auth tools and mechanisms, and you might just be providing advice on how best to do that. You might then be conducting a threat modeling workshop. This is where you get the team together, like I said, do workshops, do attacker stories, really get into the mindset of hackers, etc. You might help a team remediate a vulnerability and update a library. At 4 p.m, you might then be doing a backlog review, which is, rather than looking at the work that everyone's currently working on, look at the work that you're meant to do at some point and decide when to bring it into your sprint or to bring it into the work that you're going to be working on over the next few weeks. You might then attend a call with a third party about them using something in AWS or sharing some data in Azure or integrating with a new API, and you recommend on how to secure that API, etc. And then you might be reviewing a new SaaS product that you might want to be doing, a new DevSec tool, a new security tooling, or a new file share tool, etc. So that's sort of what the day in the life looks like. And it's a combination of being hands-on. You might be writing some code, you might be writing some Terraform for something you're deploying in AWS. It's a combination of jumping in between meetings, etc. But that I would say is what a typical day in the life looks like. SAST. So we're now moving away from principles, tasks, etc., and into the tooling. And what are the core tooling? Now, SAST, which stands for Static Application Security Testing. SAST is about running scans against the code engineers write. So there's sort of two things engineers do. They write code themselves, and there's no point writing code all the time. If someone else has written loads of code that works for building a certain feature or doing something, you can reference that library, pull that library in, and then you just write your code around it to make sure it works with your application. There's no point. This is just how engineers work now. So SAST is about the code, scanning the code that you write for vulnerabilities. So sometimes when engineers, and I'll give an example, it's called SQL injection. I'll do other sessions on OWASP, something called the OWASP Top 10, which is the top 10 vulnerabilities commonly found in web applications. SQL injection is one of those. And SQL injection is where an engineer will, I'm not going to get into the specifics, but they'll write an error in their line of code, right? They don't know they've written that error. That error that they've written goes into the repository and gets pushed into production. Nothing sees it because you're not doing any scanning. And then an attacker can see it and exploit that error externally and then steal data from the business, right? So SAST is designed to scan the code that you write, and it will say, hey, there's a SQL inject vulnerability here. This is the line of code where it is. Engineer, please fix it. And then the engineer will go, oh yeah, I didn't see that. It will educate them. They'll learn and understand how vulnerabilities work. They'll fix it. Now, the great thing about SAST is you want to capture the engineer actually writing the code. You don't want to find it in a penetration test or when it's already in production. So you shift it left and you have a scan as early as possible in the pipeline. So when you get that developer feedback, the engineer fixes the code, then it goes to production, then it's fine. Now there's two things you can do. You can run a SAST scanner in like a passive mode, which it will just alert it to the engineer as part of the pipeline. So they'll write their code, merge, they'll commit to the main branch, merge the main branch, and usually the scan will identify then. You can actually run SAST scanners within the IDE where you write your code. So like in Visual Studio Code, there's various plugins that can do that. So the engineers can quickly scan. It's unlikely they'll do that. If you integrate it as part of a pipeline job, and like I said, I'm going to do a full session on SAST, you can also block the engineer from merging to main branch unless they fix the vulnerabilities. So that's a really powerful tool. Some of the cons is that you get a lot of false positives. Find loads of secrets in your code that shouldn't be there, but not actually secrets. They're just, could be comments that's found anything in your code. Lots of false positives. And false positives mean the tool is saying you've got a vulnerability, but actually when you look into it, it's not. So it's falsely saying it's a positive find on a vulnerability. Loads of different tools in the SAST world. A lot are paid for. Some are open source and some are free. This is sort of an example on this page of what findings look like from a SonarQube job that I ran. But yeah, really, really powerful. Integrate SAST. Every piece of code engineers write should go through a SAST scanner. DAST. DAST is a bit, so when we think of SAST you can do really early on because it's on written code, it's within the IDE, etc. DAST you would want to do a bit later. Well, you'd want to do it a lot later because DAST it stands for Dynamic Application Security Testing. It's dynamic because it needs to scan moving parts of an application. The application needs to be a bit more built and needs scanning. Usually you would run a DAST scan in kind of pre-prod just before an application goes to production, but it's actually built and can be tested. Or you can actually scan it after production and on production environments as well. This finds mostly CW, or what's known as CWE. I will do other sessions on the difference between CV and CWEs, but if a DAST scanner finds something, it's very likely that that will be exploitable by an attacker. So DAST scanners are really, really key. Again, you can have them block the application from going to production. That's how you should have it. You get less false positives with a DAST scanner. And it's a prelude. You can use it before pen testing. It's a very useful tool to do before pen testing. The most commonly known tool to use this is ZAP. Burp Sweep's arguably not a DAST scanner, but there's Acunetics, Nikto, loads of other tools out there that do DAST or similar type testing. But think of it as that's more far right and SAST is more far left. And then you've got pen testing right at the end. IAC scans. So infrastructure as code is going to, I will do a complete video on infrastructure as code itself. At a very high level, when you build an application, now when you build it in the cloud, it sits on what's known as infrastructure. So it sits on like little servers that deploys the application. Now, when you deploy that infrastructure in AWS or in any cloud environment, the old way used to be is you'd go into the console, what's known as a console, and you'd click deploy, you'd deploy an instance, etc., and it'll all be done hands-on. That's changed now, and the problem with that is you have no what's called as configuration management. You don't really know who's done what, where they've done it. You don't know what the source of truth is, etc. So what you want to do is you want to deploy that infrastructure as code. So this school of thought is known as infrastructure as code. It's a big DevOps term. Everyone's using it. Almost every business in the world will at some point be using Terraform. A lot of businesses are still going on their journey of deploying Terraform infrastructure. So all that code of the infrastructure, or all the physical things actually deployed in the infrastructure and in your cloud environments should be behind the scenes all written as code somewhere. But what this has actually been one of the biggest changes I've seen in the security landscape is that security vulnerabilities and threats and concerns for a business are now no longer just about attackers externally or someone exploiting SQL injection, etc. One of the biggest vulnerabilities now is misconfiguration of infrastructure because, and there's a reason for this, in the old model of DevOps and tech businesses, you used to have a centralized cloud team. So if an engineer was building an application, they would send a message to the cloud team and say, hey, deploy this infrastructure for me for my application to run on it. That used to be the way of doing it. It's a bit clunky. You end up having to get in the queue and it slows engineers down. But what that means is that centralized team are absolute experts, know everything, know the security, know what goes wrong. So if they see something's wrong, well, they've deployed it and they've deployed it right anyway. Now what we're doing is we're moving to the engineers deploying the infrastructure without the need for that cloud team, because they're writing the code. They're writing what's called Terraform code, which is infrastructure as code. The problem with this is that they're not security experts. They're not cloud experts. They're probably just application experts, and they are just writing code. And the danger with that is they could write anything in that infrastructure, deploy a public-facing instance that should be private, deploy data within an instance that shouldn't be in there, open up security, open up ports on firewalls that shouldn't be open. There's all sorts of things that these engineers can do. So and this is why DevSecOps is now even more important, because more people, it's right to move to that model, but you need to do it with caution. So infrastructure as code scans is so critical, because what you want to do is when the engineer is writing that code, even within their IDE, you can run a Terraform scan check or a scan check off that code to say, hey, just to let you know, if you deploy this infrastructure, it's going to be public facing, or it's going to release this security thing, or you've not done it, you've not hardened that code in this way. And you can do it within the IDE, you can run it as a pre-hook commit, you can run it as a pipeline job. There's loads of different stages you can run that IAC scan. You can run passive, you can do blocking, there's loads you can do. It's absolutely key that you put in place some sort of automated Terraform scanning. It should be one of the most important things you do as part of that shift left. And another thing that you can do as a DevSecOps engineer is help advise on how teams deploy Terraforms, not just the scanning, because the scanning is more of the preventative and corrective control, but what you actually want to do is get it right with the engineers. They should be deploying Terraform correctly. So shared modules where they reference specific already built modules that have been approved by security and just add some bits on is the best way to start. If you have teams that are all blindly copying random Terraform templates from elsewhere on the web, that's not going to fit your business, right? So have shared modules that teams can work from. Really important. This is why you need Terraform as a skill. It's so I know Terraform. Well, I can't blindly write Terraform, but I know Terraform. I've deployed my own Terraform infrastructure several times before. Make sure you can deploy Terraform infrastructure. Software composition analysis, SCA, is about the code that you reference in third-party libraries and your dependencies. So we said earlier about SAST and how that covers the code that you write, whereas SCA looks at the code that you reference from dependencies. And there are vulnerabilities in those, there are CVEs within those libraries. So an SCA scanner will essentially look at those libraries and look for any vulnerabilities that are found. Now there's quite a few false positives as a result of SCA. So for example, SCA will not know if that third-party library is public facing, if certain functions are in use to actually make the vulnerability exploitable. So you have to make sure that whatever scanner you use is quite good at looking at the false positives, or that you have an exceptions process to make sure that you're not blocking teams based on vulnerabilities found in libraries that aren't actually there. And it's also known as dependency scanning. So there's lots of pros and cons to doing SCA, and it looks at out of support components. It looks for CVEs in the code itself. SCA also provides a lot of findings around licensing. Now in security, we're not necessarily so much concerned about licensing, but the product team and others might be interested in licensing. So for example, when we use libraries, a lot of companies don't realize that when they use libraries, some libraries are actually paid for libraries. You should be paying for those libraries. They're actually licensed. And so if you build a new product or a new application that's based on libraries that a different company owns, etc., that can cause a licensing problem for the product that you yourself have built. So SCA a lot of tools out there cover the licensing side as well. And you want to make sure that the SCA scanner, like SAST, is a part of the pipeline, and that it blocks at the appropriate time for the team so that they can then fix or use different dependencies, use a latest version dependency. It's also really important that you promote the teams to regularly run their pipelines to update their dependencies, because if it goes on for too long a period where they haven't run a pipeline job and the app's just been public for a year, you won't pick up those findings. Lots of different tools out there, open source tools, some free tools, some that cost. You've got Sneak, Dependabot, Veracode, various other different tooling out there to cover SCA. Pipelines. Pipelines are really, really important. Gaining an understanding of how a pipeline works, because this is the whole SDLC is typically run within the pipeline. Different teams have different pipelines, they do different steps within their pipelines, but overall, for the business that you're in, there should be a general way the steps work within that pipeline. The best thing to do is, this is an example of me using Azure DevOps many years ago. It's not that great, but Azure DevOps is a really good intuitive way to learn if you've never used a pipeline before. And you can clearly see here, you can see the step where we've got SonarQube running, we've got White Source Bolt, which does software composition analysis, SonarQube does the SAST scan, so you can see the steps, etc., and how that works. So I would strongly recommend using Azure DevOps, but there's Jenkins, there's loads of different pipelines out there. Now, chances are you'll break the pipeline, your pipeline won't work for you, but you just need to gain an understanding of how it works. And the best way to do it is deploy it yourself. So run some code, run an application, build an app, scan it, run some Terraform through the pipeline, get used to using pipelines. And it's really key that you learn that guardrails, and guardrails are basically rails that guards code engineers writing code. You build those guardrails and they are steps within the pipeline jobs. Okay. And Azure DevOps is a really good example to use that. But pipelines is the central core component of automating DevSecOps and being able to pull it out to scale. For example, if you define in the org level pipeline that all teams have to use these pipeline jobs, they'll be forced to do them. And you can make sure you've got those blocks in place to help protect teams. So the diagram I'm going to show now is a target model of how you would run DevSecOps. So when you first join a business, I would recommend one of the first things you do is you sit down with the DevOps teams, architecture teams, engineers, and go, tell me what your pipeline jobs, your SDLC looks like, and you draw out what it currently looks like, how they pick up certain packages, how they pick up container images, where all the different steps are, right the way from code, writing code in the IDE to deploying in production. Then you want to do a target version yourself of saying, right, this is where we are, this is where we want to get to, and you put that overlay. I would always do a diagram like this. So as you can see here, we've got in the kind of greenish blue, we've got the security tooling. So we've got SAST and scanning TF, which is Terraform, which is the infrastructure as code. So within the IDE, you want to scan the SAST, you want to scan the source code using SAST, and you want to scan the Terraform. The IDE is the furthest left you can go really with your scanning. Once the engineer pushes this to a repo, and before they merge it to the main branch, you then want to do another SAST, you want to do SCA, you want to do another scanning of the Terraform. But in this case, this will be in a block, it should be in a blocking mode. When you first introduce it to a team, put it in passive mode so the team get used to it and understand it. Now, the big key thing here, depends what pipeline jobs and how it's working, but you want to make sure the developer feedback is there the moment the engineer sees it fail in the pipeline build. If you are using tooling where engineers have to leave the build or the pipeline and look at a report elsewhere, they're not going to use it. It's not going to be helpful. It has to be helpful for the engineer. That's why you need that really good developer feedback. So get them that information. So if you're going to block a pipeline, straight away where they see it's blocked, they can see the reference to the line of code and recommendations on how to fix it. So they can then, when they rerun the pipeline, it will pass. So next step, we're deploying to production. So again, we want to do a container image scan here. It depends how it looks like for the pipeline. DAST and scan the TF. So DAST, because we've got, we should have an application that's pretty much very well built now, and we can hopefully do a DAST scan before we push to production. Then we want to do, once you've deployed it to whatever cloud infrastructure or the final infrastructure, if you like, you want to do an infrastructure scan after the build and before. So there's a tool you can use called Cloud Custodian, which will actually look for compliance problems in the code that you've deployed, the infrastructure you've deployed, and it can actually change the Terraform and put the engineers, force them back into compliance. So for example, if you're deploying an S3 bucket in Terraform, it will change that infrastructure and it will block that S3 bucket. It will delete and remove the S3 bucket itself. Got to be careful, because if it's referenced in Terraform, you get what's known as config drift. But yeah, really powerful there if you want to actually prevent engineers from doing things they shouldn't do. So then you want to look at doing something around the runtime scanning of like Kubernetes or whatever you're using in your runtime, how you've deployed. It could be, you might be running on Fargate, you might be running EC2s. Make sure you have some sort of runtime scanning in place to look for bad behavior there. And then the infra scan is also about what's known as cloud security posture management. So you want some sort of tool that does CSPM. I'll be doing future sessions on that. And then web application firewall, you need a web application firewall, but like I said earlier, you've got to create custom rules to the application and how it's deployed. So this is the target model. This is where you want to get to. It's sort of like DevSecOps on a page, really, but it would look different for different organizations and potentially different teams as well. Threat modeling. Threat modeling is the number one most important thing you're going to do as a DevSecOps engineer. It's the best way to introduce yourself. So doing a threat modeling workshop is the best way to introduce yourself to the team. They get to understand how you work, what you're about, and it's a really good way to start provoking conversation between engineers. So usually what I would do is I would reach out to one of the managers. I'll say, like, who's in the engineering team? Get a list of names, add them to this big workshop, schedule it for in a few weeks' time. Then I'd start asking questions about what do your apps look like, what are the HLDs, the high-level diagrams, what's the architecture, and I'd put all that information in a slide, in a PowerPoint presentation or a slide deck, Google Sheets, whatever you want to use, and start drawing out and planning how the flow of that workshop looks like. What I'm going to do is, as you can see on this diagram, there's three kind of main tools you can use here. There's Stride. These are ways you want to prevent an attacker doing what they're going to do. The cyber attack kill chain are the methods the attacker would use, or the phases the attacker would use. So I usually follow the cyber attack kill chain to, when I discuss it with the engineers, I go, right, we're in the reconnaissance phase, we're an attacker, what are we going to do? How are we going to prevent them from doing this? And then Mitro attack is a framework that goes into detail around the different ways attackers typically do it as seen in the wild. There's no right or wrong way of doing this, and you're not going to cover all threat scenarios, but the idea is you want a really good mix that covers most of the ones you're worried about. And then at the end of the workshop, you'll have a list of actions, a list of risks potentially that the team will go away to remediate to make that application. But the best thing to do is to make sure you do this as early on when you join a team, and it will develop rapport. It will help them understand where you're coming from with security, and it gives them the context of why they need to take security important. So threat modeling is really, really important. I am going to do full sessions on threat modeling. Overall tips. One of the main things you need to do is stay up to date with new practices. You could be in an organization where you're the only DevSecOps engineer. So all these engineering teams are going to be reliant on you. So you've got to make sure you're staying up to date, form parts of groups, always look online for new ways to integrate different tooling, because it's always changing. AWS is always changing, Azure is always changing, pipelines are always changing, and the tech of the business are always changing. Be a step ahead, look at AI, how that can help with launching different tooling and how you can protect AI tooling that the business are using. Loads of different things, you've got to stay on top of it. There is a big lack of understanding of how DevSecOps works. Good and bad. It's beneficial in the sense that you're going to be that kind of pivotal person and key principal person with the DevSecOps skills. It's good because the salaries are really good as a result as well, because there's that lack of supply. But it also means you really need to sell it when you get there, because people won't understand it. They might see it as a blocker. You've got to sell it as an enabler, do a lot of the things I said. Promoting new tools or the use of tools, I really recommend, if you want teams to be self-serving and actually using their tools, you need to see if there's tools they're familiar with or tools that they themselves prefer. Don't force your tools on the teams. Okay, so if someone's familiar with a SAST tool, let them pick it, let them use it, make it look like and feel like they're heavily involved. People at their desks. So like I said before about the challenges, reach out to those engineers, meet them in person, sit with them, develop that rapport. Don't just do, well, if you have to do remote meetings, obviously do remote meetings, but talk about life things as well. Develop that relationship. And that will also help with the next, which is disarming the ones that cause problems. So there will be some people that think they're security experts, and you have to make sure that they're on board with you. So the best way to do that is sit with them, listen to them with empathy, understand their problems or why they might be concerned with you joining the team or looking at what they're doing. And even say, oh, can you help me with this? I'm going to really rely on you to help me with this. And that will help make them feel a part of it and that you need them. But you have to win them around. Don't be confrontational with them. Don't go to the same level at them. Go to a level down. Okay, so listen with empathy, and because at the end of the day, they could stop you achieving your goal. Because if DevSecOps and rolling out DevSecOps is what you need to do, and they're going to be in the way of that, you've got to disarm them. And the whole term, keep your friends close and your enemies closer, I think, not quite enemies, but those people you need to work with more closer than everyone else to keep them on top. Running scans too often, yeah, you're not going to make friends if you're running scans too often and you're causing problems with the team. So again, build a pipeline, build a DevSecOps process for those teams that works with the teams that have to run it and maintain it. Running a 40 or an hour-long job that's going to scan everything and massively delay going live to production, and they have to run it several times a day, it's just not going to work. And don't force new practices. Whilst I would recommend you building a toolkit on how to do this, and I've given you all the tools to put in that kit, it works in different ways for different teams and different companies. Don't force those practices. Watch how teams work, learn and adapt with them as well. What I've given you today, this lesson on DevSecOps, is that high-level view covering all areas of DevSecOps, right? Though from working practices, how it actually works in the real-life world, to the tech to be in use, etc. as well. I'm going to be doing lots more sessions on a lot more detail on all these different components. This is that high-level view. Go away and do some research on some things I said. Get hands-on. I'm preparing you for that future DevSecOps role. I want you to. The pie is more than big enough for everyone to have a slice. There are hundreds of thousands of DevSecOps roles that are actually open and people haven't got the skills for. I have phone calls with recruiters all day, every day, wanting people, trying to hire me, trying to ask if I know other people with these skills, and there's no one in that market. So I want to get you to that point. I've learnt it the hard way, and I can speed it up, and you can do things a lot quicker than even I. I love this job. I love DevSecOps. Let's build a community. Please be a part of this community, contribute, tell us how you're getting on, how your interviews are going, reach out, ask each other questions. It's a really exciting area. These roles are going to be the most important role in tech in the future, and it's going to get bigger and bigger. Thanks for joining. Hope you enjoyed it. Reach out if you want any questions, and I'll see you on the next courses. Thanks.